Porika. I'm the founder of Virtual Network Element, VNE.io. I'm here to give you the presentation of SDN controller, and in this demo, our SDN controller is built on reusable components like Redis, Clojure, Graphite, Grafana, and our core component, the SDN controller, is built on Intel DPDK technology. Using this Intel DPDK, we can achieve very high packet processing capabilities. At our preliminary testing, we get close to 20k messages per second on a single CPU thread, that is on a single logical core. And you can get started on this SDN controller by going to our GitHub page, like github.com vneio/sdnc. And once you clone this repository, you get 4 scripts, and we are planning to add many more Mininet configurations. A first script is basically starts the SDN server, and second script stops the SDN server and all its components. So when I start the SDN server, it starts all the containers, and then it starts them in such a way that it starts Redis, then it starts Graphite, then the Nerd application. This is the Java or Clojure application that gives us the UI and the API. Then it starts the OpenFlow controller and the Grafana. And when you are starting it for the first time, it may take a while to download all the images, the Docker images from the Docker repository. So it may take maybe up to 5 to 6 minutes to start up all the to download all the images. So let's go back to the client, the UI. So the UI is your Docker host, the Docker host IP :9090/nerd client, and we can log in into the application using admin. Admin is the username and admin is the password. And here we have the Nerd API and the UI. We also have the events. These are the interactions between the switch and the server, and we also have a topology. So let's get started by firing up a Mininet simulation with 50 switches. So a linear topology with 50 switches and 50 hosts. So as we can see here, as the hosts are getting added and switches are getting added, we get the corresponding information onto the events. So let's capture a event. So let's capture all the interactions between a switch like switch 1 and the controller. So we can also see the corresponding interaction on a web sequence diagram. So here you have request, reply, and also in a tabular way. So I can click on any of the messages and gets its complete details. Here it gives you the command and also different attributes, and at the bottom you have data. Data is the payload of the OpenFlow message. Okay, now let's see in the topology. So topology, we have 50 switches here, and the connections between the switches are discovered by LLDP. Now we can also do ping all on the Mininet, and these pings capture the connections between the hosts and the switches. So if we go here in the events, so we have this OFPT packet in, and as soon as those packets come, the corresponding replies are basically controller gives them the command to modify the flow tables. Once the flow tables are modified, then we get to the steady state. So let's, and in the steady state we have only again the OPT, open flow, echo reply and echo request messages. So if you go back here, we have all our connections, and here it is still pinging, and we should have the result very soon. And we can now go back to the OpenFlow client and then see all the information on the host. So if you hover over the question mark, we get the details, and similarly if we go to the switches, we can see the corresponding switch IDs, manufacturer name, hardware description, and the OpenFlow version, ports, and the flows information. And flows, here are the flows that are programmed onto the switch, and we can also get some statistics. And once you click on the flows, these are the actions that are associated with that flow. And we are planning to add many more features, like making the topology more interactive, where we can click on a switch and get the details about the switch on the left hand side, similar to the host, the connections. And we are also we also have a API where you can program the flows proactively instead of the reactive flow programming. We plan to support protocols like OBSDB, BGP LS, so that it can support different topologies like leaf and spine. And we plan to add many more configurations, the Mininet customizations that we can test the SDN controller. Thank you for your time. If you have any questions, you can send us emails at support@vne.io. Thank you.